There's three types of collisions when we discuss collisions in a sense of momentum. There's elastic collisions, there's inelastic collisions, and there's completely inelastic collisions. An elastic collision is an ideal situation. So it's our ideal collision. And in an elastic collision, no energy leaves the system. So this is ideal. This is what we want to happen. It's very rare for this to happen. In fact, it's so rare. The only example that I have for you of this happening in real life is an atomic collision. So in an atomic collision, we have an ideal collision in which one atom hits the other, they bounce off of each other, they go back, and no energy leaves the system. So it's a completely elastic collision. So it's a collision. So the description or the definition is a collision in which external forces are so low that both momentum and kinetic energy, which we haven't discussed yet, but we will get to, are conserved. And while we're talking about collisions, we're going to go ahead and talk about what happens with kinetic energy in the collisions. And we're going to talk about and take the notes on kinetic energy in a couple of days, and we can come back and revisit these notes. So momentum in an elastic collision is conserved. So we're going to write conserved across here so we know that that is conserved. So if momentum is conserved, the momentum initial is equal to the momentum final. And our energy is conserved as well. So we can say our energy kinetic initial is equal to our energy kinetic final. So an elastic collision, again, is an ideal situation. All of the energy is conserved. All of the momentum is conserved. And our example of that is an atomic collision. And an elastic collision is completely rare. Most of your collisions in the world are going to be inelastic collisions. So this second example, or this inelastic collision, is where most of your collisions are. So most collisions in the world are inelastic collisions. A great example is a bowling ball striking a pin. So an inelastic collision, the definition of it is a collision in which momentum is conserved, but kinetic energy is not. So momentum is conserved, meaning momentum is going to be passed from one object to the next. So when the ball strikes something, the momentum is going to pass from the ball to the pen is going to fall over, or the pen is going to travel. It's going to pass its momentum from object A to object B. So when we say that momentum is conserved, the objects are going to collide, but not stick together. So under momentum, we can write conserved. And our momentum total initial is equal to our momentum total final. So that conservation of momentum law is obeyed. In our inelastic collision, it is not conserved. So our energy kinetic initial is greater than our energy kinetic final. So some of the energy is transferred, but not all. The last type of collision we have is a completely inelastic collision. So in a completely inelastic collision, our vehicles will actually become stuck together. And their final velocities are going to be the same. And an example of this is two vehicles stuck after a crash. So the description of a completely inelastic equation or a completely inelastic collision is a collision in which the objects stick together resulting in a common velocity final. Our momentum is going to be conserved. So our momentum initial is equal to our momentum final. However, our energy will not be conserved. Our energy is not conserved. So I'm going to emphasize this not here. So our energy kinetic initial is greater than our energy kinetic final. We don't have any energy transfer that's taking place here. That energy transfer here is completely non-existent. Usually we would say some but not all is transferred. That's going to be in a Inelastic, completely inelastic, we've got no energy transfer going on. So they're completely stuck together afterwards. So just as a simple review, there's 3 types of collisions. Your 3 types of collisions are elastic, inelastic, and completely inelastic. Inelastic, it's an ideal situation. All of your energy is conserved. They completely bounce off each other and all of your momentum is conserved. And completely inelastic, they don't bounce off each other. They stick together. An example of it is when 2 vehicles stick together in a crash. None of your energy is conserved, but all of your momentum is conserved. In an inelastic collision, momentum is conserved, but kinetic energy is not. Some of the kinetic energy transfers over, but not all of it. Most of your collisions, 90% of them are going to be this inelastic. But elastic collisions and inelastic collisions do occur. Momentum is always conserved. That's why there's a law of conservation of momentum. And that is the end.